Oh wow, I'm live. Hi everyone. Here we are. Yeah, annoyingly I have to say this. If you're just joining us, there's a Discord link in the description. Please join our community and also subscribe. It really helps. It's encouraging to see subscribers. We can do more stuff and we can go further. So, without further ado, let's actually fix something today. Maybe. So, over the past couple of days, I think a week or so, I've been working on this NUCLEO N6570, and what I've been trying to do is to get some video frames out of IMX219 camera. However, that has been quite difficult because basically we've been on the wrong format for quite a while. Uh, well, we were not on the wrong format in the beginning. It just didn't like the yeah. It's been a battle for the video formats, and you can see all of this for yourself because you can look at the past few streams that mention this board, and you can see what we've been doing. So, however, the last time we got through this, and I can put it up so that we can see. I can actually put it up so we can see. I don't know if my audio is working. I hope my audio is working. Damn it, my audio might have been broken, so that's a problem. Anyways, let's get started and then see what happens. So the last time we worked on this screen dev TTY SCM0, and then I think I go 11.5.200. Cool. So let's look at that, and I'm gonna reboot this thing. So here's where we were the last time. So it sort of chose PRAA, but then PRAA was incompatible with whatever else that we were using. So this actually doesn't work for us. And then at the end of it all, I kind of went onto the ST community. I mean, not ST community, the Zephyr community, and I spoke to some video maintainers, and they said this was an issue of. Let me see if I can open the thread itself. So basically, yeah. So here we go. So I went to the Zephyr community, and this is basically what they said. They said, let's see, trying to get this thing to work. Sorry about that. Try and get this thing to work. Okay, cool. So this is what they said. Let's look at it. So basically what they said was, it looks like the thing we're trying depends on, yeah. It's, for UVC, it's not yet functional. We might have to fix that ourselves. However, when doing this, it looks like, I'm looking for the message itself. Yeah, we need to look at the samples, drivers, video capture boards, STM32 and 570 basically configuration so that we can see what we need to do in order for video to come through. And this is basically where we need to join it, where we need to configure the, so let me draw this. It's easier if I draw this. So let's actually go to Excalibur as always. So let me draw this, and so let me draw this. We'll have some sort of camera on one side. You'll have a camera on one side. Let's actually put it on this side. It's easier for me. Let's put this as a camera here. So come. Okay, and then let's put some sort of like, yeah, let's call that the UC, the microcontroller. So this is the N6. This is N6, and then this is a camera, and then there's all of this. There's lanes coming from the camera here all the way to the thing. However, before you get to the microcontroller, there's a little interface over here. So there's a little interchange interface here, and this little interface is DCMIPP, and then from here it goes into the microcontroller. So this is some sort of like camera interface. It sends its video into DCMIPP, and then from DCMIPP it can go into the microcontroller, and then the microcontroller can like either like you can like kind of point it out, and then you know, you can put a display over here, And then, you know, if this is a display, you can kind of get video going all the way from the camera into the interface, into the microcontroller, into the display. So that's kind of what you can do. However, the thing that Alain was explaining to me is that the input format that is expected by DCMIPP is the one that we need to mess up with. We need to kind of find a way of configuring that, and hence we start this session with this configuration. So this thing just gives us this 6 configurations that I think we already have in our own attempt. So actually let's go look at which configurations we're using in our attempt. So I think we're going this is in Zephyr project, and then Zephyr project, and then I think we can just open a Vim here, and then let's go here. And then in here, we can go to project configuration here. So we have video, shell, device shell, printk, log. This is all stuff that we added for video. So this is fine, that's okay. And then we have a pool max number, a buffer pool size max, and all of those things. So I think the easier thing to kind of do today is to basically, I would like to go to such kconfig, and then we can plug in all of this new ones, basically this new ones, and these ones that we will add from here to the other side, and basically learn about them. Yeah, thank you, Bartholomew. I am live, and you're live as well, I think. Bartholomew is a dude. Well, I think he's a dude. I hope I'm not misgendering you by calling you a dude. But Bartholomew is a good guy, good person, and they always show up. That was like 5 minutes of me correcting myself. Cool. Anyways, Bartholomew, tell me if I offended you. So let's go to kconfig search and actually just build through config search. What we're going to do is we're going to plug in all of these. We're going to plug in all of these variables here. And what we're going to do is to learn what they mean. And then once we learn what they mean, we'll probably put them on the sample that we're using and try and see if that fixes it. And if indeed that does fix it, then it's cool. We can go on. If it doesn't fix it, we have something to report back to Alain here, Alain from ST. And Alain should be able to let us know if there's something we can fix, if there's something we can go forward with, or however way we can fix this thing. So let's actually try that. So what I want to try is, we know a few of this, but let's just go ahead and look at them. So let's start with config video frame width. So I think we know that. This is just how wide is our frame in pixels, I would say. It's missing. It's not documented. Okay. Fine, that's not documented. It's probably because this is in the new version of let's go here. It's in the new so this is probably documentation for which release? The latest release. But the latest, I think we're dealing with code that is in the next release, not the latest release. So let's actually go to Zephyr itself. Let's actually go to Zephyr itself, and we can just start looking. We can just start reading the code. Remember, gaining information is super straightforward if you just go and read the code. And if you're new here, there's links in the description for our Discord community and for the code we're working on and all of those good things. So you can kind of just join in if you want. Yeah, so let's look. Config video frame width. So let's actually put that in here and do this. I could grep it, but I won't. It's easier. So I want to see, this is actually where it's used in the samples video capture main, but we're not going to use that right now. What I want to see is where it's kind of defined. So it might be just this. So actually, let's just look at where it's used. Yeah, you should take me to the line. Yeah. Sorry. Okay, cool. Let's actually jump there. Let's see. How is it used? if config video frame height or config video frame width, then if config video frame height, set the format height to that, set the format frame width to that. So it looks like this is just used in the main sample. They don't seem to be actually kconfig variables, so that's fine. That's okay. We can use them and we can see. And then the other thing, the other part that we wanted to see is this. This are used as the frame width and the frame height that we need to get from that. This is set to the format. So the format needs to give us this. And then there's a video pixel format. Pixel. It looks like that also only appears in the sample. So video pixel format. It looks like that only appears there as well. Config video pixel format. Let's look. Yeah, RGBP in the sample boards and all of that stuff and all of that good gestures. Yeah, they're all in the video capture samples. So yeah, this seems like it's used in capture main or probably UVC as well, but yeah, it falls back to that. Yeah, okay, cool. So also, if you set a pixel format, the interface will pick it from here and it will try and comply to that. So let's actually see. I don't see how that works because, but wait. Alain did say that he did use, Alain did mention that he did actually use PBAA, so that's fine. We can probably end up. So where did Alain say something? Yeah, what format? Yeah, it's advertising the BA81 and PBAA. When I played with the PR from Joshua in the past, I used the PBA format apparently, since that is what is written into the conf file for the other board. Cool. So we'll see if we can. We'll see if that's what we end up using. So it doesn't look like this is a real kconfig variable. So we'll actually start from something of the sort, and then we'll go from there. Yeah. And then the next part is going to be, let's actually check on the next thing, which is format. We've chosen that. Let's look at this. I'm hoping this is actually a thing. So this is size of the largest buffer in the video pool. Cool. So we can even actually go where it's used and stuff and see. And this says, where are you? I can't see contrast because of my somehow my screen isn't letting me see contrast. Somehow it's just not good, but I hope this is visible for you guys. Yeah, sure, that's fine. So in size of the largest buffer in the video pool, so that's okay. Buffer pool size max. Okay, cool. That's okay. Okay, cool. And then let's actually keep going. And then what we want to see next? Video buffer pool nut. So this, I think this is number of buffers. Number of maximum size buffer in the video pool. What? So there's a pool of buffer and number of maximum size. So yeah. Okay, cool. I get it. So the other one we just looked at was the size of the largest buffer, and then this one we're looking at is how many such large buffers can we have in the video pool. So basically that's what we're doing here. Okay, cool. So that's good to understand there. And then config main stack size. Config main stack size is that. Copy. Yeah, let's look here. Config main stack size of stack for initialization and main. Okay, cool. So this is just the stack for the main thread. So that's fine. That's okay. Cool. So actually, let's actually try and apply those configurations in our own thing and then see if that actually works out. So the first thing I want to do is to make sure that we are on somewhere like sane. So we're not actually changing stuff that is, where's this? I am going to close this. So I'm going to leave that open, and then this I can leave here, this I can leave here, and then in here, this is fine. And then here I will sort of do a source. I'll just .van.bin.activate. So I'm gonna start that, and I'm gonna do this, and then here I'll do the GitHub stuff. So cd Zephyr, or the git stuff, git status. So let's see what we've changed here. What I want to see is this git diff boards. Let's look at that. So I want to actually put this back to the normal endpoint, because this is the dump pipe. If mostly Bartholomew was here, but if you recall correctly, we changed from using the main pipe into the dump pipe, and I'll show you where that is right now. It's in the, we'll see that document just now, and we will be able to kind of like find it out. So NUCLEO N6, yeah, okay, cool. And then there's an application. So there's application node 6211, and this is DCMIPP for STM32 MCUs. So previously we tried this. We tried to change. There's a place where the pipes are sort of shown. The pipes are shown somewhere, and I want to display that. Okay, cool. So there's a pipe 0, and then there's a pipe 1 and a pipe 2. Pipe 0 is just a dump, as a dump pipe. So from the camera all the way into the IP, an IP is hardware for, in FPGA land, an IP is just a block of hardware that can be used in a certain way. So this is a plug into some other thing. This is basically the reception port. And then you see pipe 1, post-processing pipe 1 and post-processing pipe 2 involve going through the ISP. So we had disabled this, and we went to pipe 0 so that we could try that. So, but right now we're going to try and just go back to pipe 1 and see if that works out. So git status. I'm going to stop just now for questions. Git check out boards, only boards. Yeah, just git status. Okay, cool. So that's fine. So now this actually puts us back on the normal pipe. So first of all, let's actually build it and see what happens, and then after we build it and see what happens, we can kind of do west board dash b west. I can't think. Build dash b NUCLEO west control that west build. Yeah, this is the one. Samples video capture pristine. That's actually exactly the one we wanted. So let's remove that and let's actually build that. And while it's building, I'll stop for questions, and let me go back to YouTube. Yeah, any questions so far? Yo, Nathan! Papa! What's up, man? I'm pretty good. I hope you are well as well. We have a build in progress. So if anyone has any questions, this is a good time to ask them. I can answer some. Doesn't matter how simple your questions are, just welcome. This is why we do this. This is why we ask questions. Okay, Nathan. Hey Nathan. Hey Bartholomew. Hey everyone else who's live. Nice to see you. Nice to meet you. Yeah, Nathan. Nathan's been learning. Nathan says, I have been learning device tree, man. That's cool. That's cool. What have you been learning? What difficulty are you facing? Can we answer some questions or something? Can we answer some questions while this thing is building? Whenever I'm building, please feel free to ask questions and such. Yeah. No questions. Well, he doesn't. He says he's been learning device tree. Doesn't say if he's faced anything hard or something or whatever. So we'll let him ask a question later, and then when we come back to YouTube questions, we can kind of answer it. So okay, cool. I've put my thing in bootloader mode, and I'm gonna West flash it. West flash, and let's actually see what happens. So it's gonna flash now. That's amazing. And then I'm gonna put it back to. Gonna put it back to here, and then what I'm gonna do is I'm gonna do a reboot, I think. And if I go here, we should get this. Oh, there you go. Well, yeah, there's not that many layers between the DTS to actually using the drivers, and I can show you just right now. Let's actually. This is a learning session. I do this so that I can learn. So I might as well just free you up and let you actually see what is happening. So let me show you this. So the camera that we're using today, Nathan, we're using an IMX219. Okay, cool. And so there's a driver for the IMX219. It's written in C. Let's actually go and find it. So let's actually go and find that driver, and I'm gonna operate from like. As you can see, this is let's actually quit this, and then I'm in the Zephyr project, just the root directory. So I'm gonna start my editor here, and you can see here VM, West, applications, bootloader, build, all of this are like modules and stuff. So in here we have the Zephyr folder, and inside the Zephyr folder we have something called drivers. So inside this drivers, if I go to video, I'm going to show you. If I go to, I'll just do video. If I go to video, in here we'll find a file for, since today we're working on the IMX219, we will find the IMX219. I'm not going to look at the kconfig rec. I'm going to look at the C first, IMX219.c. Okay, cool. So here's the driver for this camera, Nathan. Let's actually open that. So here's a driver for this camera, and it's made by the people at work, and it's really cool. And now you guys kind of have an idea why I keep testing this and why I like this so much. But what I want to show you is it has a DT-DRV compat, and that is device tree driver compatible string. That's what that lines mean. That's what this line means. The device tree driver compatible. So this is just code that is just sitting there, okay? And this code, you can activate this code by selecting something called device compatible string, and I'll show you how we're using this in the application that we're using. So let's go into this application. This application that we're using has a camera, and you can see on this camera there's Sony IMX219. So this is literally the compatible we're looking at. So the comma becomes an underscore, and if I do Control O, and you'll see Sony underscore IMX219. So we are activating this driver. We are activating this driver by labeling something compatible to that driver. So this camera, we took this hardware camera, and we labeled it compatible to the DT driver compat. So now you know Control 0. Now you know where the driver, the C driver of the camera lives. So now I'll now show you how the layers are actually not that many. So the way Zephyr knows which driver to use so that it can connect the one that is the right one is it uses something called a DTS binding. And we'll come back to this folder just now. Actually, let's actually do this. Let's actually just IMX219.c. Yeah. Let's just space A, Control E. Okay, cool. So we'll come back to this, and then PV, and then let's go here. Let's go back out, and let's go into the Zephyr folder again. So I'm gonna go back into the Zephyr folder, and in the Zephyr folder you'll find something called DTS. There's a DTS file. There's a DTS directory. In the DTS directory you'll find something called bindings. These are bindings, okay? So in this bindings, the folder bindings literally follows the drivers folder. But I do know there's some non-device trees and some non-device tree elements. So don't just take my word for it's not as straightforward as that. But to learn it is simple. So in the DTS bindings, I can just go video, and inside video we can find I can do IMX219, and then you can see here. So there's Sony IMX219. It's named the same thing, and all it defines is this is a camera. This thing presents as a camera, so it shows itself as a camera when you connect it. However, when you connect it, you use I2C to talk to this thing. That's what the binding says. So the binding just tells you how, and then sometimes what happens is whenever you need to use a device, it might come with more requirements. Yeah, it might come with more requirements, and that means you get this thing called 219. You get this thing called a config, yeah, and this is that thing. It's a kconfig. It's basically how you enable the driver. So kconfig allows you to enable stuff, and here you can see config video IMX219. It's an 8 megapixel composite metal oxide image sensor. It uses I2C. It depends on the device tree. Has Sony IMX219 enabled. It defaults to Y if you used it, and that's it. Those 3 files is how device tree works. You might have to come back to the video and watch that part again, or you can ask questions right now. I can explain it again. But that's, you have the driver, you have the binding, and you have the kconfig. And if you have those 3, you can connect all of those, and then you can just use it in your code. That's device tree for you. That took me so long to understand. That took me like months to understand. The fact that I can run through it in 5 minutes now is like insane, amazing. Anyways, Nathan, you can ask questions later when you have. But now I think the next part that we wanted to do is now we want to follow. I like to follow this the recommendation of. I'd like to follow Elaine's recommendation and actually use the configs that are presented in here. And I've seen Nathan has more questions, so we'll just paste them in, and while it's building, we can go back to Nathan's question. So I'm kind of copying them all, and I'm gonna copy them. I don't like copying stuff. I like typing it over. Let's actually stay correct to what we need to do. Config video frame width. I don't like copying stuff because then I don't learn anything if I just copy it, and I'm wasting my time. I'm wasting everyone's time, so it's fine. And if I copy it, then I'm just a normal, This channel has no magic in it. There's no magic in this channel, so. Okay, and then I think this was something like 800 and 480. Okay. So that's 800. And then config video frame height equals to 480. Config video frame video pixel format, video pixel format. So they're using RGBP. I don't know that it's gonna work because it's saying PAA, but you know, let's trust the powers that be. Let us trust the powers that be. So buffer pool size max 800,000. Buffer pool size max. So let's actually bump this up to 800,000. 800,000. But I kind of don't want to do that unless we run out of. Yeah, I'll leave that, and if we run out of memory, then I'll come and change it. But I'll leave that in for now. So and then we'll come and change it. I think you need it because. Yeah, I wouldn't do the main one. I wouldn't change the buffer pool number max, and I wouldn't do the main stack size. I will just do the ones associated with video. If we do run out of, if we do actually run out of RAM, we'll come back and change these two. But they seem to be using more RAM rather than using less RAM. So I don't know. Let's build this, and then while we build this, we can go back to more questions. Yeah. So let's build this. Okay, let's go back to Nathan's questions. But the DTS files have to be compiled somehow, no? Yes, they do. They actually do. So actually, that's such a cool thing that you asked that at this time. So look at this here. So it will find the device tree overlay. This is the device tree overlay that I just showed you. Okay. And then when it finds that, it will generate a complete device tree called Zephyr DTS. And basically what it does is it's going to combine the changes that you've applied here with the existing board package that Zephyr has. So it combines those into one Zephyr DTS, and then that's the one you use in your application, basically. Yes, they are combined. And by specifying the build, you see when we go to build a thing, we specify West build board B. We specify a board. By specifying this board, we've already said use the device trees for this board. So because if you go back to Zephyr itself, here, I'll go back now to Zephyr. Zephyr has something called boards. So Zephyr has something called boards. Well, there's a directory called, yeah. And in this directory called boards, there's going to be an ST directory. I'll show you. There's going to be an ST directory. By the way, just because there's a lot of stuff, you don't have to be scared about it. Half of these things I've never gotten into. So you just, and the person who's working on Scilab stuff has never gotten into the ST one. So you don't have to know everything. You just have to know the ones you want to use. So, and then I'm going to look at NUCLEO, I think N6. So I'll just show you how it comes to be, how device tree comes to be, and then you never have to ask this question again, from now on. So here's a NUCLEO N6570, whatever. So that's what we choose here. Okay, this has actual device tree here, and there's a lot of things in here, but you can put almost everything in here in one device tree. It's just broken down like this so that it's easier to manage. Yeah, like you see, the actual device tree doesn't have anything. It just includes the things. Okay, it includes, which means the common one is actually the one we use the most. So that's the device tree. So when you actually go and say build with that board, it uses that board. However, sometimes you add some code or you add some devices. You take your board, and then you add a device to it. And then what I've chosen to use now is called an app.overlay. And in the app.overlay, as you can see here, in the app.overlay, I've just basically described that I've added a camera to this thing. That's all. That's all I've added. I've just I'm telling the device tree, I have added a camera to you, deal with it. And this camera that I'm adding uses a Sony IMX219 driver, deal with it. And then what happens there is my code will go and it will build itself, and it will join itself, and it will combine, and then it will make a combined device tree. Okay, and it will make a combined device tree that lives in Zephyr build Zephyr Zephyr dot build Zephyr. Yeah. Whoa, if you go Zephyr build, that's an actual thing. So if you need, oh wow. Okay, so build Zephyr.dts. Okay, so it'll make this file, and this file is basically a combination of all those things. You'll see it says something like node defined in Zephyr boards NUCLEO blah 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 blah, and then if you come back down to like the camera itself, if you come back down to the input clock, it will say defined in Zephyr samples driver video capture overlay. So it just shows you, it just combines all of these little files. Yeah. Well, you don't put the, you would put the emulated driver right next to so I'll show you the emulated driver I know. I'll show you the emulated driver I know, so that you're not confused about. This is exactly why we do this session, so that people can ask questions and we can all get good together, and I can learn what I don't know, because a lot of times Bartholomew teaches me things by asking me questions, and Nathan as well. So emulated drivers will just go into the driver folder, and they will, in actual sense, I want to go to fuel gauge, because that's the guy who promotes emulation worked on fuel gauges. And now in fuel gauge, you'll see that I think it's maybe the SBS one. I don't remember which one has an emulated driver, but let's see. Yeah, so you see, it will just go to the drivers folder, Nathan, and you just make a separate sitting emulator. Yeah, basically, here you go. There's the code for you. Emulator for SBS 1.1 compliant smart battery fuel gauge. That's where it lives in the drivers. So the way you choose an emulated driver is you just choose that. You just choose that. But you wouldn't, if I go back, I bet you if I go to the SBS gauge.c, it uses the same thing. SBS gauge, new API. So, okay, cool. That doesn't use the same one exactly. But, well, if you go to this, it actually does use it. SBS gauge, new API. So, the thing is, when you're using, like, the fuel gauge subsystem, if it's a subsystem, will have an emal runner. So when you use emal and you pass in, you will pass in whichever driver you want to pass into it. It's a little convoluted. It's a little kind of all over the place. But if you bear with yourself and you keep trying, it all connects. It's a lot of little things to connect rather than just one magical thing that works. Basically. Anyways, we've changed the kconfigs, I think. Let's look at this. Let's actually look at some code again. So we've changed the kconfig, so let's actually look at catdeffer.config, and then I think in here we can grab video pixel. So this should tell us if it's actually activated. Yeah, so it's RGBP. So in here, where we go, RGBP has been chosen. Basically, this means these ones have been activated. So if we go frame width, frame height, we can actually look at those two. So let's actually look at those two. So frame video, actually let's say video frame. Let's see. Yeah, frame width, frame height 480, frame width 800. So the two settings that we've added are actually active. So let's try and run this. I'm gonna put my board into bootloader mode. I really miss the old boards that you just flash it immediately. You don't need to do bootloader mode, all of this fancy stuff and everything. You just go flash the thing immediately. Let's flash. So let's see if that works. Okay, cool. So that's actually connected, and then I'm gonna unhook this, unhook that, and then I'm gonna reboot, and then let's see what happened. So first of all, It never says video capture started, but it doesn't crash. I kind of want to choose PBAA because of this. Look at it. Look at it. Look at this. Look at this part. So it did say that what it did say when I played with the PR from Joshua in the past, I used the format PBAA. Apparently, since this is what is written in the conf file for the other board. So let's see if that actually changes. This is, first of all, this is really good because it sort of works. It sort of does work because it's not crashing, but it's also actually not giving us what we want. So actually, let's see. List devices. No. It's devices list. Device list. Yeah. So there's it all pump. So there's a video format. So let's actually look for video. Ready. Okay, cool. So let's actually do video. There's no video driver. Oh no, there's no video shell. So there's no video shell. I see. So there's no video shell. So it doesn't really work. We never activated the video shell. So let's try do PBAA and see what happens. And then if PBAA doesn't work, and then we can just kind of give up. Yeah. PBAA. That's kind of what I want to do. And then I want to see if that actually builds. And then we'll take a couple of questions. Number one, this actually really works. So the first thing we need to do actually is to reboot this thing and take a recording of that, because we have to report this. We have to report that happened. Can I go here? And can I go like just? Why is it that when Nathan's on the stream, I have hay fever? So let's actually progress. So let's actually do that. Let's get that. Let's just copy this. So that's RGBP, and then let's look at this and let's put that there, and then let's actually go to the next one. I'm gonna say, yeah, I'm gonna put it there. Let's do something else. I think because Nathan keeps asking, we might actually end up building an emulator. Nathan, do you want us to build an emulator? I have no problem like just doing what you guys want, because this is what you people want. I keep saying guys, and that might make me sound very sexist. I don't want to. I'm saying Nathan makes me sick, and we should arrest him so that he's in jail when I'm streaming, so that I don't have. Nathan's asking me, what are you trying to say? And I'm basically saying, whenever Nathan's on the stream, I get hay fever. So maybe Nathan should be in jail when I'm doing this, so that I don't have to get sick. You know, I'm also human. I kind of need a chance not to be sick. Hopefully I'm neat. My face is not like boogers going everywhere and stuff. I would assume you guys would tell me, so it doesn't really matter. So I want to try with PBAA, and it's sort of almost the end of the session. This is amazingly good progress. Number one, to be able to like get there. Everything used to end in a crash, but right now it doesn't end in a crash, so that's kind of cool. We can also activate the video shell, and yeah, we can activate the video shell. So let's try PBAA. If that doesn't work, we're gonna activate the video shell and try and start a recording and see how that works, and then leave it at that. This is perfect. It looks really good so far. So this actually looks better, but it doesn't say capture started. So it could be that it needs us to choose a frame interval or something of the sort, and then we can go forward for it. So it's fine. So one good thing would be to activate the video shell, and let's actually look at here. So I want to know video shell. Config video shell. This shell provides control and query commands for video drivers. So we'll do that. Make sure that the jail opens inwards, because if it opens outwards, Nathan is gonna come for me. Dude. Yeah, but sure, if like for real, Nathan, if you're keen, just say it. I would say it on the Discord so Bartholomew and everyone else can vote, and we can do an emulator. I wouldn't mind doing an emulator driver. If you guys force me to do one, I will do one. So let's actually put the thing in bootloader mode, and then I'm gonna do a West flash. Okay, cool. Like Bartholomew actually forced me to do a lot of audio stuff, which I have to go back to, by the way. We have an audio project that's hanging in the air. we got sidetracked by fixing Zephyr. So that's actually done. So I'm gonna do that, and then I'm gonna put it back, and I'm gonna reboot it, and then let's see. Aha. So PBAA is not supported. No. You look, Nathan. Let me record this somewhere. Let me record this. Actually, there's a reason that the developer who was talking about emulators was a Google developer, and they actually ship a lot of stuff. I know it feels like it. But I promise you, emulators are actually for the more advanced developers. It might feel like it. It might feel like, wow, why would I do an emulator? But here's the thing: the people from Google are the ones who are doing emulators. So legit, like, don't be. Okay, here's the thing. Here's the scenario. We all live in like very far parts of the world, Bartholomew is in Poland, and Poland could be stolen by Russia anytime. No, I kid. I might have even touched on that. That guy has clicked unsubscribe. Fuck this guy. I hate him. Anyways, Bartholomew is in Poland. Nathan is in Kenya. I'm in South Africa, and we all work for like very remote places. So here's a place where an emulator becomes really cool. Emulators are devices that you can use when you have the documentation. So say you have a datasheet for a device, but you don't have you have a datasheet for a device, but you don't have the device yet. Sometimes, I've been in this situation at work. I am in this situation right now at work. Sometimes you have a datasheet and the device has not been manufactured. They're going to manufacture it Q1 next year. So you have a choice. Do you wait until Q1 next year to start on the code? By Q1 next year, you'll already be 4 months late because you already got the job today. That's how I'm serious. This is how embedded works. You got the job today, and someone's gonna make a hardware later so that you can use, and you can't wait until that is ready because you'll be getting other jobs then, and you need to pay rent and all of those things. And basically, you end up needing to develop a sort of pace. You wanna be ready before this thing gets to you, and if you can do it in such a way that when the thing gets to you, you already have some code. As vibe coders, or as AI developers call it, you have some boilerplate to start with. You're already 90% ahead. I promise you, you're already floating ahead of a lot of people. Using emulators is not for kiddies, actually. Kiddies wait for hardware, and then when they have hardware, they start coding. But if you're serious about this, you build an emulator, you build a driver against it, you test your driver against the emulator, you put it on the side, you go on to the next job. And you do that, and you do that, and you do that, and you do that. And then suddenly you meet these people who feel like they know a lot. But they don't know a lot. They just don't wait. They start as soon as they can. So don't feel bad about having to write emulators or something of the sort, or using emulators. It's actually the top of the world. The people who are really sharp and really going for it, they're using emulators, and it's making them go faster than you and I, and we need to do that. Okay, so don't look down on emulators. They're really I'm not saying that you look down on emulators. I don't know you, but well, I kind of know you, but you know what I'm saying. I don't know that you know what I'm saying. It's I got myself into trouble there. So let's enable the video shell. I'd like to do two things. Let me enable the video shell, and I would like to try, you see here, it goes like lowercase p. I would like to try that, and then we'll see, and then we can try that. So let's try a couple of few things. Let's try with lowercase p here, and then we can actually just let's enable the video shell. Why? So that we can actually do video stuff, you know, to see if it actually works and whatever. Again, I'm gonna do a build. We can do questions right now. Any questions so far? As always. As always. Bartholomew is quiet, which means he's trying something. Bartholomew, what are you trying? I've had to drink coffee today. I hate it. I don't understand how people drink coffee. Worst tasting liquid ever. And I'm only drinking coffee because there's no tea in my house. I don't know why there's no tea in my house, but I know who to blame. Yes, yeah, Nathan, yeah. There's a thread on the Discord. Nathan's asking, you mentioned earlier that Zephyr doesn't have an audio stack. Zephyr also does not have a video stack. Would you believe that? Zephyr also does not have a video stack. We're building it. That's why all of these things are PRs in progress. Zephyr also doesn't have a video stack. So Zephyr has a lot of video drivers. Audio drivers, and it has a lot of like audio interface drivers like I2S and I2S and what is I2S, SAI, PDM, and all of those, but it doesn't actually have an audio stack. Bartholomew, we just haven't got back to it because we need to fix the machine learning part, and we have to wait for the people who know machine learning to help us with our machine learning code. Bartholomew says, I think I abandoned this audio project too, and I need to get back to it. You'll get back to it when you can. That's you guys are learning the nature of embedded. Embedded just takes long. You just have to work at what you have to. And this is where emulators become really important, because sometimes you're in this no man's land and you're just kind of waiting for stuff. And when you're waiting for stuff, you can do stuff. Okay, so like right now we're waiting for someone to help us with the machine learning side of stuff, and then we can go for it, the Python-y stuff. I'm not good at Python. I can't read Python. Let's just say it that way. So let's do a West Flash. What does this enable? This is just a video shell. Oh wait, I meant to say, yeah, okay, cool, that's fine. This is okay, cool. So PBA and a video shell. Cool. So let's actually hook this up properly. And then I'm gonna reboot it, and then I'm gonna come back here. Okay. Video. So yeah. Video start. So I think we want to use endpoint 1, video start endpoint at 1. Why? Okay. Endpoint 0. Okay. Endpoint 2. Fair. Okay, cool. So this is with the small p. And I don't see that it actually works. So what I'm going to do is go to RGBP here again. And then I'm going to try and use those commands and see what happens. Yeah, and then we'll see what happens. And then RGBP. RGBP? That sounds like, that looks like I used it wrong. That definitely looks like I did something wrong there. RGBP, yeah. I think I did RGPB, yeah. Done another thing. So let me start building and then I'll do another lecture. So, boom, 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 mini lecture session. So, Bartholomew, don't be afraid. You don't have to finish everything you start. Sometimes you just start things so that you can learn stuff. And then once you've learned things, you don't need to do them. Because remember, the point of all of this is to learn how to do stuff in Zephyr. Well, for microcontrollers in my case. And super tiny computers, you know. Talking about like NAND gates and flip-flops and all of those things. So we want to learn how to use those things. And I'm basically responding to Bartholomew, and he says, I think I abandoned this audio project too, and I need to get back to it. And I'm saying, number one, we will get back to it. Well, I will get back to my audio project because we need some machine learning help. We need some machine learning algorithms for us. And then 2, not 3. Well, 1, 3. Bruh. Anyways, 1, 2. Sometimes the point of doing stuff is that you learn the thing you're doing rather than actually finishing the thing you're doing, you know. It's like those people who end up writing compilers, not because anyone's going to use them, but because they're wanting to learn how to write compilers. So there's this, sometimes in life we overbear ourselves with things that, you know, don't worry about putting something down and never getting back to it. But then also worry about that a little, you know. You shouldn't do that over and over again, but maybe it is your thing to do that over and over again, you know. I'm going to flash it. Wait. I'm going to put it in bootloader mode, and then I'm going to flash it. So I think this one is RGBP with a video, So Nathan is asking, what is the issue with the machine learning thing? So the issue with the machine learning thing is we need DCT coefficients. We need DCT coefficients, and we need DCT coefficients and some other list of coefficients so that we can actually do MFCC extraction. And then Bartholomew asked, do you have many hobby projects started? Yes, I have a lot of them. Many. I'm doing so many of them. What I've found to be the thing is to maintain a list of all the projects I've started. And then to just genuinely attempt to finish them. You know, I'm not forcing myself. My hobby projects, some of my hobby projects have ended up becoming the thing that I was known for, the thing that I worked for, and all of those things, and so on and so forth. So I do have a lot of hobby projects. I just try and keep moving each one 1% ahead. But then I have some hobby project that I started when I was a web developer, which is like 5 or 7 years ago. I see no reason to go and do them now because I don't work in web anymore. I'm not interested in that. I understand how it works. I start hobby projects to learn how things work. Once I've learned how the thing works, I don't know. Yeah, you see, Nathan was also doing, I think, some sort of, Were you doing JPEG compression, Nathan? Or are you doing that in C or something? Yeah, the discrete cosine transform can be like super silly. Anyways, we've flashed this thing, I bet. So let's actually look at what it says. Cool. So I'm gonna reboot it. Doesn't make sense. Oh, cool. Sorry, I need to actually go back to app mode. I wonder if this allows my thing to keep going. Okay, so let's actually do video. Video start, and then it'll just fill it out for us. Go along. Okay, cool. That's amazing. So let's actually do video start, end point at 0. No, I feel like this didn't actually do the correct thing. So let's actually just flash it again. Or maybe let's actually build before we flash so that we know we're on the right stuff. Let me save this and let's build this. I got carried away yapping and I didn't pay attention. Yeah, so Nathan was doing JPEG and he also got stuck at discrete cosine transforms, but he will also get back to that. And he says he was using Golang. So if you want to use Golang to do JPEG stuff, I don't know if you're doing JPEG compression or what sort of JPEG thing you're doing, but if you want to do JPEG and you have some insight into working with discrete cosine transform, Nathan wants your help. But in general, if you know how to do discrete cosine transforms, which I think Bartholomew knows and likes very much, we all know we need your help. Yes, I'm just building it again. I yapped a bit too much and then, I lost where I was and I'm sorry about that. This is actually good. Our session today has been quite powerful because we've sort of figured out stuff. We know how it crashes now with RGBP, which is a different way it used to crash than it was crashing with, PBAA. So this run might actually end up working because this is RGBP with yes, with the video shell. So we might be able to start video and see what happens. So okay, cool. Let me put it in bootloader mode, and then what if I do this? Yeah, cool. It's in bootloader mode. So I'll do west flash. Okay, cool. And then I'll flash it. Ah. Okay, cool. And then I'm gonna reboot it now. And then let's see what happens now. Yeah, so video start. Okay, cool. And then let's actually try and use endpoint 1 before we use 0 and 2. So just we can see video start endpoint at 1. So it just wants PRAA 2592 1940. Okay, cool. And what if we use endpoint 0? This is a dump pipe. Okay, cool. So this seems to be let's actually do video format. Video format and point at 1 in. Okay, out. Oh, okay, so cool. So this doesn't seem like it's working. But if we do remove the shell, this is actually quite promising because we no longer have a break. And and I think we've gone over the time, so I can see it's 5, and we will go and look at that later. But that has been good. It's actually good because this is actually, I think the way at the pace we're going to end up fixing the IMX219 on the DCMIPP, and we might also end up fixing UVC itself. So this is quite good. I just hated that I couldn't stream yesterday because I had promised to check this out for a lane yesterday, and I didn't. Life can be like that. I also hate that I didn't stream because then I didn't hang out with Bartholomew yesterday and Nathan. So that's really unhelpful. Anyways, so what have we done today? We've really played with exploring the IMX219 camera on DCMIPP, and it sort of works. This is what we're building towards right now. It sort of works, but I don't think it gets to capturing frames. So the next thing we're going to do is we're going to take the report that we've gained and go give it back to a lane, and then we can see what we can actually fix. And this is the part where the other alternative is just jump into code and try and read everything and see what I can, but I have a day job to go and do, so I won't be doing that now. What I'm only going to be doing is just adjusting this and reporting to a lane, and he can tell me what's broken, and then from there on we can kind of like work together to go fix it. So, putting it in bootloader mode, and I'm going west flash, and this is RGBP, and I want to show this is just basically to show how far we've come in this session. So we went from like a proper crash, and now if I reboot it, we are actually quite close because we don't get a crash. You can tell it's actually good because we don't get a crash, basically. Yeah. Any questions to close off? I'm still going on with this. We're going to do another stream tomorrow. If my internet is good, I'm going to take this report back to a lane right now, and then we can see. I mean, these people know a lot more than me, and this is why these people exist. You have to use them for the things you need. Yeah. This is why I exist. You guys everyone here can use me for what they need, basically. Any questions so far? It was a good walk through device tree today with Nathan, so that was pretty cool, and it was good answering Bartholomew's questions, so that was pretty cool as well. Other than that, it's been an awesome hour with you. Thank you so much for showing up today. I'll leave you guys and you gals with that for today, and we'll see. Nathan is asking recommended boards. What do you want to do, Nathan? What would you like to do? It depends on what you want to do. So, Nathan, there's this little board, and you can get it from, I think, Pixel Electric in Nakuru, or Thika, or I don't remember. There's also a shop in Nairobi as well. But there's this little board. It's a blue pill. It's a STM32F103. I don't remember how much it would cost you. It should cost you like something like 1,000 or less. Probably less than 1,000. I think it's less than 1,000. Let's actually see. Or even from Nerocas, I think. You can't really do crypto on a cheap board. Nathan, what would your budget be? So there's I think in here I can go like blue pill. If you're trying to do crypto, are you trying to do crypto mining? Or just cryptography in general? Nathan. STM 32. Bartholomew, I don't know what crypto means here, but he could be wanting to do something like crypto. Yeah, so you probably then don't want, Nathan, you probably then don't want, if you want to do cryptography, blockchain stuff, you probably don't want embedded board. You want, you're going to want something like an FPGA or an ASIC, basically. And then that will also mean, because it's very hard to get cryptography IPs exported out of the US. You will likely end up needing to implement your own crypto IP block for for doing stuff. It's not that easy, but it's not that difficult as well. It's just very involving. Any more questions? Any more questions? And then we can close up this session and go report to Elaine what happened. Any more questions? Yeah, get some sort of FPGA, Nathan. But FPGAs are not gonna be pocket friendly. Where I work, we do sell this. So you might wanna maybe you can consider getting this one. This is actually a really good let's do by UP. Do we know? But I think the importing into Kenya is gonna be quite yeah. So there's this one. You can buy this one. I don't know if you can do that. I don't know if you can do $36, but that's a good FPGA. It's going to be microprocessors are going to be very slow at doing cryptography stuff, so you'll need some sort of programmable I/O stuff so you can arrange the fabric yourself and whatever. So maybe this is what you want or something, but you would need get this one, learn on it, and then when you need a beefier one, you can go get the bigger ones and whatever. And you can also get the tiny NUCLEO NX, so you can get the big bad boy, the big boy. You can get my desk. You guys don't want to see the side. It's like insane. You can also get this one, Nathan. This is our flagship product. That's our flagship product, and this is tiny NUCLEO NX. This one. You can get this one, but this is like a beefy monster. I don't know where you can buy it. Yeah, let's see, order online. I don't know where you can buy it, but yeah, there's a store here and you can get it, and this is the one you need. But in order for this one, no, this is system module. But okay, I'll explain now. So you need this one, but you also need the dev board as well. Okay, because it's just the actual board that I just recommended to you. The actual board that I just recommended to you is this part. This part. If I don't know if it shows correctly, this little part. But you can't really do much with this little part. You need this bigger board so you can use the USBs and things like that and all of those ports. Otherwise they're not exposed, they're just pins and you need them. But I would advise start with there's also in the middle between those, you can also actually in the middle between those, there's this one as well. There's something called Pico Ice. Pico Ice too. Yeah, so there's this one. There's this Pico Ice. This is the mid-range. So this is the mid-range between the bigger one and the smaller one. So there's this one. That's That's the one that's on screen. That's a Pico Ice. And what it has is a Raspberry Pi. It has a Raspberry Pi, I think 2350, and an Ice 40 Ultra Plus 5K. So this is the hugest one. This is like the mid-range one, and then this is where's the tiny one? Where's the tiny one? You know the tiny one, Nathan, the Upiduino one, and that's the one we've built like a little. Nathan has been very keen on those streams. That's the one we've built the little processor on, basically. That's a Upiduino one. That's the smallest one. So yeah, pick them. Choose the one you want. Choose where to start. Start something, really. That's really the whole story. Yeah. Thank you all so much for showing up today. That was amazing. Let me go report our findings, and then we can reconvene tomorrow, and we can do some more stuff, learn some more stuff. As always, thank you so much for coming. And if you're watching this later and you got this far, please subscribe and like the video. It really helps. It helps people seeing this, and if people can see this, I can do it more, and we can grow the community more, and that's actually the aim of all of this. Thank you all so much. Cheers. See you. Amazing.